sum of the interior angles of a polygon. Okay, so you already know what is the sum of all the interior angles of a triangle.
180.
Exactly. And that's why that logic works. Now, if you take a quadrilateral, this kind of looks like a kite. Now, what do we do to find out the sum of all the interior angles? We see how many triangles can we make. Okay, so we can make 2 triangles inside, right? And that's why you know that sum of all the angles of this triangle will be 180, and this triangle will be also 180. And that's why you do 2 times 180. How many triangles do we have? We have 2 triangles, right?
Mm-hmm.
That's why you multiply 180 by 2. Okay, can you tell me the sum of all the angles of a pentagon?
Mm. A 7-sided shape. Oh, no, 5-sided shape. Yeah.
5-sided, yeah. 1, 2, 3, 4, and 5. So first of all, we need to check how many triangles can we make.
You can make 3 triangles, so is it 540?
540. Very good. So 3 times 180. Okay. Now, Megan, if I ask you, what will be the sum of all the angles of a polygon which has 50 sides? I don't know. I cannot even draw a polygon with 50 sides. But obviously, there would exist a polygon with 50 sides, right?
Mm-hmm. I got 8,640 because then
How
it would
did
just have
you?
40. Because it would just have 48 sides. I mean, 48 triangles in it.
Very good. Very good. You identified this pattern by yourself, or did you
Yeah.
know the form? That's perfect. So whatever is the number of sides in a polygon, so if it is 50 sides, you have to do 50 minus 2. That gives us 48. And you have to multiply that by 180. So we have a formula, Megan, for an n-sided polygon. If you have a polygon with n sides, the sum of its interior angles is given by n minus 2 times 180 degrees. And I'm so happy that you actually came up with this formula. You came up with this formula by yourself. So this is sum of all the interior angles of a polygon.
Wait, so is the n like the side, like the sides, like how many
And
triangles you get?
no. N is the number of sides. For example, in pentagon, value of n is 5. Okay. So when you do 5 minus 2, that's when you get 3. 5 minus 2 gives you 3, right?
Oh. Mm-hmm.
So you don't need to draw the triangles every time. You can use this formula instead. Okay.
Mm-hmm.
Similarly, for your quadrilaterals, how many sides do we have? 4. So n is 4. So that's why when you do 4 minus 2, you get this 2. So you don't need to draw the triangles every time. So you can use this formula. N minus 2 times 180. In school, have they taught you this formula?
Yeah, they did a little, like we saw, like we started it, but we didn't finish it because the class was over. But like we saw that.
Okay. All right. Now this was sum of all the interior angles. Now we come to sum of all the exterior angles. Okay. Now first let's understand what are exterior angles. I'm going to draw some shape. So Megan, what are the exterior angles? Do you know?
Like the outside angles.
Which one? Do you mean this one?
Yeah, because I remember learning about like alternate interior, exterior. So like, but also like parallel lines.
That's different. That's for parallel lines. See, exterior angle, you said that the angles which are outside, but they will not be simply this angle. No. The exterior angles are formed when you extend a side of a polygon. If you extend this side, then the angle that you get, this one, this is an exterior angle, okay?
Mm-hmm.
Now, if I extend this side, then this one is exterior. Okay. Then if you extend this side, these are your exterior angles. Now we are interested in finding out the sum of all the exterior angles. And you will be very happy to know that for every polygon, the sum of all the exterior angles is always 360 degrees. Sum of all the exterior angles for every polygon, okay? For every polygon is 360 degrees. Whether it's a triangle, a quadrilateral, a pentagon, a hexagon, anything. Now, this might be difficult to digest, right? That why is it like for every polygon, how can it be 360 degrees? Don't you think?
Mm-hmm.
So this is your exercise. You have to think why the sum of all the exterior angles of every polygon is 360 degrees. You have to think. Okay?
Mm-hmm.
Okay. Now, Megan, have you done the homework?
Yeah, I'm almost done with it. I'm just like confused with like the last couple questions, but I'll try and figure it out soon.
What did we do in the previous class?
It was like a review of everything.
Yeah, review of all the quadrilaterals. Okay, Megan, you have to send me the solutions. Okay?
Yeah, I'll try and send them to you like a couple hours before the class happens, not like right when the class happens.
Yeah, not just a couple of hours, but try to send it to me at least 12 hours because I just wake up before because the classes happen in the mornings.
Mm-hmm.
Like for the next 2 weeks, since I'll be taking your classes in the evenings, so those will be my mornings, and it's like really early. So try to send the homework at least 12 hours before. That way I can review everybody's homework. Okay. Okay, Megan. So we have covered in polygons the topics that you told me. We have covered all the topics. Okay, there is one more thing. The measure of each angle of a regular polygon. I asked you one question here. I asked you what will be the measure of each angle of a regular pentagon. Can you tell me what will be the measure of each angle? First, tell me what will be the sum of all the angles for the pentagon.
Wait, so 540?
540. So 540 will be the sum of all the angles. And in regular polygons, each angle measure same. So if you have to find out the measure of each angle, then all you have to do is you take 540 and divide that by number of angles. How many angles do we have? 1, 2, 3, 4, 5. Okay.
Mm-hmm.
So you know that sum of all the angles is 540. You just divide it by 5 and you'll get 120.
I got 108.
No, you're right. That's my mistake. You'll get 108. So each of these angles that you see 108, these will be all 108, 108, 108, 108. Okay.
Mm-hmm.
But this only happens for regular polygons, that you can find out the measure of each angle. But you cannot find out the measure of each angle of an irregular polygon. Here they will be all different. They are not same.
Wait, so you can only find the measure of a regular polygon? Oh, you can
if you can find out the measure of each angle, then you can find out only for regular polygon. But sum of all the angles will be still 540. For a pentagon, this plus this plus this plus this plus this will be 540. But now you cannot divide by 5 and say that each of these will be 108 because they are not equal for irregular polygons, you know?
Mm-hmm.
Okay, that's why you have 60, 60, 60 because you divide 180 by 3, you get 60. But that's not true for any other triangle. This is only true for equilateral triangle. Okay?
Mm-hmm.
Okay, that completes everything.